So we're going to focus now on getting the derivative of a given function using implicit differentiation. So this is a method that we use in getting the derivative of a function in case the x and y variables in the given equation are intermixed. For example, in our previous videos, we were doing explicit differentiation, wherein the given function is in the form of y is equal to f of x. So how do we perform implicit differentiation? First, we need to take the derivative of every variable. And whenever we're getting the derivative of the variable y, we have to multiply it by dy dx. And then solve for dy dx. So let's say we are asked to get the derivative of y squared minus x squared is equal to 4. Let us perform first explicit differentiation by solving for y of the given equation. So this would be y squared is equal to, transposing negative x squared to the right side of the equation, we have x squared plus 4. So solving for y, we can raise both sides by 1/2. Therefore, y is equal to x squared plus 4 raised to 1/2. So from this given equation, we can now get the derivative using chain rule. So this would be dy dx is equal to, by chain rule, we can have 1/2. And then let's copy the inside function. And then we have 1/2 minus 1. And then we take the derivative of the inside function, and this would be 2x. And then we can cancel 2 to simplify. Therefore, the derivative of the given function would be x times x squared plus 4 raised to negative 1/2. Or we can write this as x over x squared plus 4 raised to positive 1/2. So this is the derivative of the given function using explicit differentiation. Now, how do we perform implicit differentiation of the given equation? So let us get the derivative of y squared. So this is 2y. And since we are getting the derivative of y, we have to multiply this by dy dx. And then minus the derivative of x squared is 2x is equal to the derivative of 4 is 0. So why are we multiplying dy dx whenever we're getting the derivative of the variable y? In this case, we are performing chain rule. And remember that y is a function of x. Therefore, there is an inside function for this variable y. So to continue, we need to solve for dy dx. So we have 2y dy dx is equal to positive 2x, transposing negative 2x to the right side of the equation. Now we can divide both sides by 2y to get dy dx alone. So 2y would be cancelled, same with 2 on the right side of the equation. So dy dx is equal to x over y. So this is now the derivative of the given function using implicit differentiation. So how is this answer equal to our answer in the explicit differentiation? Remember that earlier we solved for y, and y is x squared plus 4 raised to 1/2. So this can be written as x over, and we have x squared plus 4 raised to 1/2. So we have the same answer. Let's see, here we would like to get the derivative of 3x squared plus 2y squared is equal to y plus 4x. So the derivative of 3x squared is 6x plus 4y squared, the derivative of that is 4y. And since we're getting the derivative of y, we need to multiply this by dy dx. And then the derivative of y is 1. And then, since it's y, multiply this by dy dx plus 4 for the derivative of 4x. So let us combine all the terms with dy dx on the left side of the equation. So we have 4y dy dx minus 1 dy dx is equal to 4 minus 6x. So transposing 6x to the right side of the equation. And factoring out dy dx, we have dy dx times 4y minus 1 is equal to 4 minus 6x. Getting dy dx alone, we can divide both sides by 4y minus 1. So this would be cancelled. Therefore, dy dx is equal to 4 minus 6x over 4y minus 1. Here we're using y prime for dy dx. So the derivative of y is 1, and since it's y, we need to multiply this by dy dx, or y prime is equal to the derivative of sine 2x is cosine 2x times 2 plus the derivative of cosine 3y is negative sine 3y, and then the derivative of 3y is 3. And since we are getting the derivative of y, we need to multiply this by dy dx, or y prime. So this would be y prime is equal to 2 cosine 2x minus 3 y prime sine 3y. And then combining all the terms with y prime on the left side of the equation, we have y prime plus 3 y prime sine 3y is equal to 2 cosine 2x. Factoring out y prime, we have y prime times 1 plus 3 sine 3y is equal to 2 cosine 2x. And then we can divide both sides by 1 plus 3 sine 3y, and here also. So this would be cancelled. Therefore, y prime is equal to 2 cosine 2x over 1 plus 3 sine 3y. So this is our derivative. For 2xy is equal to 1, we need to use product rule, wherein we can use 2x is equal to u, and then y is v. So for the formula of product rule, we have u v prime plus v u prime. Solving this, u is 2x times the derivative of v, or in this case y. The derivative of y is 1, and since we're getting the derivative of y, we're going to multiply this by y prime plus v, and that is y, and the derivative of 2x would be 2, is equal to the derivative of 1 is 0. So this would be 2x y prime plus 2y is equal to 0. Now let us transpose 2y to the right side of the equation. So we have negative 2y, and this would be 2x y prime. And then let's divide both sides by 2x. to get y prime. So this would be cancelled, and also this 2. Therefore, y prime is equal to negative y over x. So this is our derivative. So for this example, we need the formula for base e. So remember that the derivative of e raised to u is equal to e raised to u times du dx. And for this part, we would be doing product rule. So let's say this is our u and this is our v. So again, we would be doing u v prime plus v u prime. So now for the derivative of e raised to sine x, we have e raised to sine x, and the derivative of sine x is cosine of x plus, so again, we're going to perform product rule here. So we have x times the derivative of y, so that is 1. And since it's y, we are going to multiply this by dy dx plus v, that is y, variable. And then the derivative of x is 1, is equal to, the derivative of 2x is 2, and the derivative of y is 1. And then since it's y variable, we need to multiply this by dy dx. Simplifying would give us this one. And let us combine all the terms with dy dx on the left side of the equation. So we have x dy dx minus 1, and then this is dy dx, is equal to negative e raised to sine x cosine x minus y plus 2. And then factoring out dy dx. So that would be dy dx times x minus 1 is equal to negative e raised to sine x cosine x minus y plus 2. And then dividing both sides by x minus 1, we have negative e raised to sine x times cosine x minus y plus 2 over x minus 1. So this is our derivative. For our last example, we are asked to get the derivative of the given function using implicit differentiation, and we need to evaluate at negative 1, 1. So the derivative of x squared is 2x. And in this case, we need to perform product rule. So this would be plus. So we have 3x. And then the derivative of y, so that would be 1. And since we're getting the derivative of y, we need to multiply this by dy dx plus y and the derivative of 3x, so that it would be 3, plus the derivative of y squared is 2y, and then multiply this by dy dx is equal to, derivative of negative 1 is 0. So let's have this as 2x plus 3x dy dx plus 3y plus 2y dy dx is equal to 0. Let us have the terms with dy dx on the left side, and those terms without dy dx would be on the right side. So this is now the equation. And then let us factor out dy dx. So that would be dy dx times 3x plus 2y is equal to negative 2x minus 3y. And then dividing both sides by 3x plus 2y, we can have dy dx is equal to negative 2x minus 3y over 3x plus 2y. So this is our derivative using implicit differentiation. And to evaluate at negative 1, 1, let us substitute this to our equation. wherein x is -1 and y is +1. So we have -2 times -1 minus 3 times 1 over 3 times -1 plus 2 times +1. So this would be +2 minus 3 over -3 plus 2. So this would be -1 over -1. And to simplify, this would be +1. So the answer to this question is 1.